My name is Andrey Nikishin. I'm a special project director of Kaspersky Lab. And I'm probably aware of the company. We are working in cybersecurity. Personally, myself, I'm working in cybersecurity for about 20 years already. And throughout my professional career, I met a lot of new breakthrough technologies which wanted or desired to change our lives. And then most of the people saw the opportunity or benefits. I usually see the risks and threats. Sorry, I'm kind of hacker, but that's my nature. And today I'm not going to tell you about the possibilities or opportunities that Internet of Things could bring to our life, but mostly tell you about the risks and threats and the way how to make our life easier and secure our Internet of Things world. You know, if you browse, you definitely already browse the expo and notice that at the moment we're running dozens of applications of Internet of Things. We can talk about connected houses, connected enterprises, connected warehouses, connected planes, connected cars, connected fridge and coffee makers, and definitely connected houses. And recently we started talking about connected pets. You can remotely feed your pet if you are away, or I'm absolutely sure that in the future you can remotely pet your pet because you are away and your dog or cat wants some more attention. You can do it remotely. And definitely it's going to be connected human. One of my friends already got the RFID chip in his hand. It's like a cyborg. And he can pass the underground barrier, not waving the Oyster card or any other card, but waving the hand, and the barrier is open. Very convenient, actually. The first real cyborg in the world. What's actually the main difference between IT and IoT? This logo truly represents the difference. The IT world, it's only cyber. It's limited to cyber world. Only digital. Internet of Things, in most cases, this is cyber physical. It's a physical device connected to the internet somehow. And as for me, as a cybersecurity expert, the main consequences of that consequences of successful cyber attack on cyber physical device would be absolutely difficult to consequences of cyber attack on the digital device. What's the worst case happened with your computer? Okay, you can see the blue screen of death, like this, or this one is a modern one, or you've got a ransomware and you have to pay some money in order to unlock your computer. What you can do, if you do a regular backup, you will lose a couple of hours restoring all of your data, and that's it. Nothing really happens, probably apart from your bad mood and spending a couple of hours doing the very, not very funny things. But if we look at the Internet of Things, the consequences is different due to nature of that. It could be like that, or that, or in best case, that. The difference is, is significant. Internet of Things devices are vulnerable. That's by default. We assume that all of the devices are vulnerable. There are security breaches and definitely privacy issues. One of the latest examples is the breaches or vulnerabilities in pacemaker. You know that some of the model of pacemaker, they got the remote control and remote management of the data. So it's possible remotely gather the information stored in pacemaker. It's very convenient because if you got a pacemaker, you come to, for assessment to your doctor, and doctor do not ask to undress and put the device on your pacemaker. It could be done remotely without undressing. But you see, there is one very interesting thing here. It's a battery. not to battery, to the electrical battery to run the pacemaker, but also make electric shock in case of heart malfunction. And moreover, this feature could be engaged remotely. The only thing to do that, you need to know the serial number of the pacemaker. So if everyone here uses that pacemaker and I know the serial number, I can remotely kill these people. And the distance is about 100 meters. If you use a proper antenna, on the distance 100 meters, you can kill this person. Another example is a remote hack of Jeep, which made by Charlie Miller, Chris Valasik last year, and they continue their research this year. This is a very remarkable example. It's possible to fully control the vehicle sitting, 1,000 kilometers away, because this particular model of Jeep 2016 was ability of connection to the network, to the 3G or 4G network. And they get an IP address, and if you know the VIN number or some other information, you can remotely connect to this device, and exploring number of vulnerabilities, you can get a full control of the vehicle. You can turn the wheel, you can press the brakes or accelerate the car. You can, turn on the radio, turn off the radio, and so on and so forth. You got a full control over this device. And the last example here, I can't say that's vulnerability. That's, as the researchers said, it's a good example of bad engineering in building the hard stack. HART is very widely used remote wireless protocol using in the industrial environment. It's not a vulnerability, but the bad engineering. And the main reason why it happened, we found out the two main reasons why it happened. First one, it's actually, reflects the nature and philosophy of big companies, which got a very long history of safety. They focused on safety, they've got a lot of experience, and they simply forget about security because they never thought about safety. That's actually the good example. The HART, vulnerability, it's a good example of that. Engineers thought about safety, how to make device safe but not secure. The second reason, it mostly represents the startups because IoT is a very hot topic. Everyone wants to introduce something and took a place on that. And almost all of the startups, we want to introduce the products very soon as possible. And they have to sacrifice some functional. Can you guess what kind of functional they sacrifice? Security. And the result is obvious: wrong risk assessment or no risk assessment at all, and cyber risks underestimated. But before I go on, let me give you my definition of what is safety, what is security. That's my own definition. You can read in Wikipedia or another dictionary different definitions. But I believe that safety is a set of instructions, what to do and what not to do. If you follow the rules, nothing bad happens. The safety helps to protect against foolish or random actions, like instruction in microwave. Never put the cat or pet into the microwave if you want to dry it. Never. That's a safety. In contrast, the security protects against those who never follow the rules. Have you ever heard about hackers who follow the rules? No, they are kind of out-of-the-box people. Moreover, they intentionally try to break the rules. It's breaking the rules in their nature. So security is to protect against clever and intentional action. That's the main difference. Foolish and random, or clever and intentional. So now everyone tried to combine safety and security and create the safe and security product. That's good. But in most cases, it's almost impossible to create equally safe and secure device. Our approach is different. So our idea, our vision, instead of making safe and secure overall system, let's divide the safety and security, and let the software itself maintain the safety, okay, functional part. And the operating system which lies below the level will maintain the security. Let's divide that. How to achieve that? Actually, the approach is not very new. So probably you've heard about that. It's based on the so-called Mills architecture. The idea is very obvious. Let's isolate and separate different applications, every driver in the system. So separate them on the hardware level. They have no ability to interact directly with each other or even know existence of other devices. All of this different part, let me show it like here. They can communicate with each other with only one way, through the microkernel, very small kernel. It's not like Windows kernel or Linux or macOS or BSD or whatever. It has only one or two APIs. Just get the communications, check it, and allow or block that. And the cornerstone of this technology lies below that, below kernel, the engine which checks the communications is blocked or allow that communication. So it's informational flow control. But this classical approach got one very big disadvantage, as I see. So they say, okay, informational flow control. That means that, this approach like one size fits all. But in our life, we have so many applications for Internet of Things that approach actually doesn't work. So we need a flexibility. So we just modified this approach and offer the flexible informational flow control. Flexible means that any type of security policy can be used. Actually, in the IT world, there are many of different approaches in security policy, like role-based access control. It's like a military style. If you're a colonel, you definitely get access to very high secure documents. If you're a lieutenant, you've got just a few part of it. If you're a soldier, you have nothing. You just follow the rules. That's it. Follow the orders. Or control flow. That's just algorithm. If you can go forward, then turn right, then turn left, that's the algorithm. You can't do anything else apart from that. And so on and so forth. And moreover, in real life, it's very often we need to combine different approaches. For example, role-based access control and control flow. That's the flexibility. Let me give you an example, because all of this stuff was theory. Let me give you a real-life example. Let's imagine we have a smart house. Truly said, I haven't got smart house, I really don't want, because I do believe that most of the modern smart stuff, it's not very secure. So probably in 10 years' time, I will have it. But nevertheless, the key technology here, not the sensors, but a gateway that collect all of the data and connect to the internet. Not the sensors, not the fridge, nothing, but a gateway. It's probably that type of a gateway, but I'm not sure. This is one, it's not very good example. It's very ugly. This two is much more, sexier and looks better. So this is the cornerstone of every smart house. If you look at the software stack, that's pretty much typical example. You see, there are a lot of different applications and drivers. And moreover, most of them somehow connected to the internet through the TCP/IP stack. Most of the gateway software are monolithic. It's a huge piece of software with an enormous surface of attack. Security, definitely it's in place, but in most cases, not often, that's an encryption. It's a common belief that encryption, that's a cornerstone of the security. That's not true. Yes, it helps in data in motion protection, but not always. Usually very weak authentication, and that's it, nothing more. And the ability to attack, possibilities for hackers for attack this system are huge. A lot of software. What we need to do, what the developers need to do in order to secure this system. First of all, rethink and redo architecture to separate all different drivers, all different applications. Think about security requirements. Think about objectives. What kind of objectives they want to achieve in order to secure the device. And definitely constraints. Build the threat model. It looks very, very scary. But in reality, it's just for that type device, it's about a couple of days of work of thinking how to attack the system and build the secure threat model. Select security domains, separate them. And then it's a defined security policy with accordance of objectives, constraints, and requirements. It looks very simple, and I'll give you an example. Just imagine we have the software updater inside of the gateway. Nowadays, it's very common functionality. And they have, 1, 2, 3, 4, 5, 6 objects here. Definitely network, it's Wi-Fi commonly. We have a downloader, which downloads the update. Verifier, which verifies digital signature of the downloaded update. And the update manager, which asks the confirmation from an end user and apply the patch or update into the device. And definitely we have device driver and different applications. This is a very simple example because it's very teeny tiny part of the functional of every IoT device. But nevertheless, this is one of the very important things. If you look at the control flow policy, it looks very straightforward and very easy. So we start from waiting for an object. If we've got the update is ready to download, we downloaded it, verify the digital signature, is everything is fine. We ask for a confirmation. If we receive a confirmation, we apply into the package. That's it. But it means that the verifier can directly call the package applier and skip the step on confirming. If this model, okay, let's give me back. This model is trying to jump over verifier directly to the update manager, this communication would be blocked. That's it. Device is secure, you can't skip the additional step. And even the hackers find the vulnerability in downloader, the only thing they can do is just to pass through the verifier, but not jump over and apply the malicious update. It's very easy. This is, like how developers see that. I prefer this type of picture, because I like visualization. This is the way how developers see that. It's a kind of language. Let's think of making it a little bit more difficult. Let's combine dynamic flow policy control with static type enforcement control and add more features. So just imagine that this part is more complex and we need to specify which exactly model have an ability, have a rights actually to talk with other models. Downloader can communicate only with verifier. That's it. Verifier can communicate with downloader and update manager, and applications can communicate with driver, actually. It's driver. Another type of a policy. So this example shows that we can combine two different types of policy, dynamic and static, into one and provide additional level of security. You can say this example is not very relevant. This is a very easy example to understand. That's why I provided that. In reality, the security policy could be much more complex, but much more flexible and reflects the requirements of the device. Let me give you another example. So please raise your hand who of you can understand this any kind of software programming language. So whatever. Oh, thanks God. Most of you can understand that. Just imagine, you're a software developer, and you've got the task to write a piece of code responsible for password checking. Okay, like for this one. Allow 3 attempts without any delay, then make a delay for 60 seconds before entering the password again, then make a delay for 300 seconds, and so on and so forth. You are not very experienced, you're a junior developer, what to do? You are writing a code. you're writing the code, you start again, ask for password, check the password. This password is incorrect. You increase the count of the password entering, show your message, and if it's below the 3, go start again, and so on and so forth. Okay, but it's very poorly, you know, I'm very junior software developer. Can you spot the mistake here? I'll give you 5 seconds. Okay, here it is. If the number of password entered less than 3, go start again. If 4, delay. What if 3? It means when in this case, on the attempt number 3, even though you enter in the wrong password, you will get access to that. Definitely, it's a very stupid mistake, okay? Very stupid. But in reality, all of the mistakes, okay, most of the mistakes are very stupid. But imagine if you have a chance to separate security and the functional. The code could be like that. Can you make the mistake here? Very doubtly, really. Even if you are a junior developer, you can't make a mistake in 10 lines of code. And the rest of the thing is somewhere on the security engine, which actually checks here, sits here. Behind the one call, it does all of the necessary security engines. What's the consequences of that approach for businesses? You know, most of us are businessmen, they count the money. The consequence is very easy. Now, you need to have one very skilled developer who understands the safety or functional part and security and can develop a safe and secure device, code. That's very complex, you know, believe me, my word, because I work in a security company and they need that type of developers. That's, you know, diamond in the rough to find this type of a developer. In our approach, you can separate and you can find a less expensive, a less experienced functional developer who just follow the specification and develop normal code, and the security expert who can create a security policy. Moreover, both these guys could work simultaneously, and you can decrease the time to market. You can release the product sooner without sacrificing functional or security stuff. So in the beginning, I told you about safe security versus safety. That's a wrong approach. We can't, we can't say that's a security against safety. We should tell about security for safety. So we need to implement the security measures in order to increase safety features. Because of the nature of Internet of Things device, they're connected to the real world, and maintaining the security, they increase the safety. You know, pros and cons are kind of conclusion of that. So, as I said, policies, the right security policies allows to a manufacturer to increase the safety and make the device safer. It's a hacker-proof approach. So, actually there is no such a thing as 100% cybersecurity. That's another topic for a presentation for now 45 minutes, but nevertheless, believe me, there is not such a thing. But this approach raises the bar as high as possible. In this case, it's very difficult to infiltrate and hack and get a full control of that type device if the security policy implemented in a proper way, in the right way. This approach can be verified and validated. You can, using the very small operating system, very lightweight operating system, you can mathematically verify it that that operating system does only thing that was implemented, that was documented, but mathematically proof. There is no backdoors or any additional functional. That's very important. And based on that, you can trust the operating system. If you trust the hardware, trust the operating system, and based on the approach, you can trust untrusted third-party device because third-party software, because of approach, because of a security policy, you can trust the overall device. In our world of cyber espionage, a lot of accusation, a lot of problems with that. That's a very important thing, to trust your device, because every device got ears. It could report somewhere or to someone. That I wanted to tell you, so I'm very fast and finished a little bit earlier than I believed. So if you have any questions and don't want to answer at the moment, so we have a booth. Just come to the booth and I can give you more examples how to make your devices secure. Moreover, on the booth they have a special demo stand of how to make a secure existing industrial object. That's another story, how to make it secure, because I showed you examples of insecurity of the real world, show the Chernobyl case. Chernobyl is not, thanks God, it's not the case of the cyber attack. But nevertheless, at the moment, now, then power plant is connected to the network, to the internet. Everything is possible. And I do believe personally that won't never happen in the future. But nevertheless, theoretically, it's possible. So thank you very much. If you have, yes, I've got some questions.
Hello, my name is Daniel. I work for Intel's security team. And the question, one of the last comments you had there was to have the hardware and secure boot enabled for securing really devices and trusting third-party software. I see today that a lot of the companies that are not really security-oriented. Can you hear me?
Yeah.
Oh, sorry. I see that a lot of companies find applying security practices and even adopting existing technologies hard. So even if they are purchasing devices or hardware that supports things like secure boot, they're not in practice enabling and utilizing it to the fullest. What is your opinion on how to make that better, and specifically for IoT domain?
The problem is, as I see that at the moment, we haven't got any regulations on IoT security. No regulations at all. I know that European Commission is working on the, like a framework how to make it secure. And they divide it on 4 different levels how to make a device secure. A device should be secure from a ground level, from bare metal up to the applications. And as far as I know, that will help to build like kind of trust around the IoT. And I can't say they force the manufacturers to do that, but if they want to have a label, trusted device, they have to follow some rules or some recommendations. I think that initiative will help us to build the trust around that, around the IoT. Not the hype, not the marketing stuff, but the trust from the cybersecurity. That's as I see it. Anyway, thank you very much. We have sometimes for coffee, tea, or anything else. If you have any questions and want to ask me personally, just I'm all yours. So thank you very much.